This only?
No, sir. Previous slide, sir.
Okay.
The one before this.
Yes. Go ahead.
This
Sorry
one.
for
Thank
introduction.
you,
I
sir.
was actually forget to start live. Okay.
No problem. Here we can see the net irrigated area and gross irrigated area. The physical amount of land present in the field, it is called as net irrigated area. Suppose a farmer is having 1 hectare land and he is irrigating 4 times in a year. Here net irrigated area is 1 hectare and gross irrigated area is 4 hectares because he is irrigating 1 hectare of land 4 times in a year. That's why it is called as gross irrigated area. And one more important term is there irrigation intensity. It can be calculated by dividing grass irrigated area with the net irrigated area, that is irrigation intensity. Next one is base period. Period in days during which irrigation is supplied to crop, that is called as base period. Suppose maize crop is there, its duration is around 120 days and we are irrigating for 20 days at different times. That is called as that means base period of maize crop is 20 days. Next one is conjunctive use of water. It refers to the use of saline water in combination with canal water. That means using of different sources of water to irrigate the field, that is called as conjunctive use of water. Next one is green water footprint. First, generally green water is known as amount of water present in the plants, that is called as green water. And green water footprint is volume of rainwater consumed during the production process. We all know that for producing trees and crops, water is required, and two types of sources will be present. Either we irrigate the field or with the help of rainwater they grow, and volume of rainwater consumed during the process is called as green water footprint. It is generally measured for agriculture and forestry products. Next one is grey water. Grey water is nothing but wastewater generated in households and office buildings without fecal contamination, and it is the water from bathrooms or sinks, wash machines, that is known as grey water. One more is there black water. Although it is a wastewater, black water is full of fecal matter and urine. Major difference between grey water and black water is grey water is wastewater without fecal contamination, and black water is wastewater with urine and fecal contamination. Next one is virtual water. It is a new concept introduced by Tony Allen. It is a hidden flow of water. If food or other commodities traded from one place to another, we know that generally exports and imports happens between one country to another country. Suppose for producing 1 kg of wheat, 500 liters of water is required, and we are transporting that 1 kg of wheat from India to USA. That means indirectly we are transporting 500 liters of water from India to USA. That is called as virtual water. Next slide, sir.
Just a minute.
Next is soil moisture constants. This is an important concept in irrigation. We all know that soil moisture will be present. Moisture will be present in the soil at a different types of levels. It may vary from time to time. All those contents are expressed as soil moisture constants. 3 types are there. First one is saturation capacity. It refers to the condition of soil at which all macro and micro pores are with water, and soil is with maximum water retention capacity. We all know that 2 types of pores are present in the soil, macro pores and micro pores. At saturation capacity, all macro and micro pores will be filled with water, and excess water above saturation capacity of soil is lost from root zone as gravity water. And saturation capacity generally happens after heavy intensity of rainfall, or if we give higher irrigation to the field, then field will reach saturation capacity. Next one is field capacity. Field, according to Weimer and Hendrickson, field capacity is the amount of water held in soil after excess water has been drained away and rate of downward movement has been decreased. We heard that macro and micro pores are filled with water after heavy amount of irrigation or rainfall, and after 24 to 36 hours, water present in the macro pores will be drained away. Water will be only present in micro pores. At that time, that condition is known as field capacity. At field capacity, soil moisture presented range from 0.1 to 0.33 bars. Here we can see that depending upon soil texture, it ranges from 0.1 to 0.33 bars. Soil texture means sand, silt, and clay. Here 0.10 it is for clay soil and 0.33 it is for sandy soil. And field capacity is also known as upper limit of available soil moisture, and it is influenced by size of soil particles. And here clay particles are there. They are less in size. For them, field capacity is high, and sand particles, for them, size is high. That's why field capacity is less. So this content is inversely proportional to the size of particles. Next one is permanent wilting point. Permanent wilting point, it refers to the water content at which plants do not get enough water to meet the requirements and they start wilting permanently. And it is generally expressed in percentage. And two types of wilting points are present. First one is temporary wilting point. Next one is permanent wilting point. In next slide, we can see the difference between temporary wilting point and permanent wilting point. Temporary wilting point, it is used to donate the soil water content at which plants wilts during the daytime, but recovers during night time, or they recover when kept in a humid chamber with saturated air. It is known as temporary wilting point. But in the case of permanent wilting point, it's wilts permanently, and even if you keep the plant in humid chamber or night time, they fails to recover. That's why it is called as permanent wilting point. This permanent wilting point is the lower limit of available soil moisture. The soil water ranging from temporary wilting point to permanent wilting point is generally known as wilting range. It is present at the range of minus 15 bars permanent wilting point. In this diagram, we can see soil moisture constants. In first diagram, field is at saturation capacity. Here we can see all macro and micropores are filled with water, and water is moving downwards because of gravitational force. In the field capacity, macropores are empty, only micropores are filled with water. This field capacity, it is available for plant growth, it is the upper limit. And in the wilting point in this diagram, all macro and micropores are empty. No more water is available for plant growth. That's why it is known as wilting point, because plant starts wilting at that point. Next, soil water means moisture present in the soil, known as soil water. And three types of soil water is present. First one is gravitational water. It is because it stays in the soil for very short period of time. Water present between 0 to 0.33 bars is known as gravitational water. It always moves rapidly down towards the water table. The influence of gravitational force, that's why it is known as gravitational water. And it is of no use to the plant growth. Next one is capillary water. Capillary water is present in the soil between 0.33 bars to 31 bars between field capacity and hygroscopic coefficient. Here we can see 0.33 bars are minus 33 kilopascal. In the irrigation chapter, these units are very important. We should read about these conversion rates also. 1 bar equal to 100 kilopascals. We should remember that one. And the entire portion of capillary water is not available to the plants. Water between 0.1 bars to minus 15 bars, only that range is available to the plants. And it is present in the capillary pores. That's why it is known as capillary water. Next one is hygroscopic water. Hygroscopic water, it is held tightly in thin films of 4 to 5 millimicrons around the surface of soil particles at or more than 31 bars tension. That's why it is known as hygroscopic water. It is also not available to the plants. It is a thin film of water present around the soil particles in the vapor form, and it is held tightly around the soil particles. This hygroscopic water and gravitational water both are no use to the plant. Only a certain portion of capillary water is useful to the plant. Here we can see classification of water in terms of biological point of view. It is divided into two types. First one is available water and next one is unavailable water. Available water is the water present between field capacity and permanent wilting point. Available water in the sense it is available for plant growth, and permanent wilting point, it is we already discussed lower limit of available water beyond which it is absorbed strongly so that plants cannot extract it. And at field capacity, water is held in the range of 0.1 to 0.3 bars. And unavailable water is hygroscopic water plus gravitational water plus certain amount of capillary water. It is not available to the plant and of no use. That's why it is called as unavailable water. Here we can see movement of water through soil. Three types of movements are there: saturated flow, unsaturated water flow. The next one is vapor movement. Saturated flow is, we already discussed about saturation capacity. This saturated water flow occurs in the saturated condition. It is the movement of water under saturated soil condition. This water flow, next one is vapor movement. This saturated condition mainly occurs because of gravitational flow. Next one is unsaturated flow. It occurs mainly because of metric potential. And and unsaturated flow depends upon two factors: hydraulic conductivity and driving force. Driving force in case of unsaturated water flow is metric force, metric potential, and driving force in case of saturated water flow is gravitational force. That is important bit. It is the only difference between saturated water flow and unsaturated water flow. Water always flow downwards in the case of saturated water flow, but in unsaturated water flow, movement is in two directions, both downwards and sidewards. Next one is vapor movement. We all know that water always moves from high water potential to low water potential. Vapor, it always moves from moist soil to the dry soil because of difference in vapor pressure. But this vapor movement through soil is of no use to the plants. Generally, it is useful only for the plants which are suffering in drought conditions. Next slide, sir. Next slide. In dry soil, vapor movement may be considered of significant importance to the plants growing in dry conditions only. That means drought resistant plants. Next, soil moisture characteristic curve. It defines the relation between energy status of water and amount of water present in the soil. As soil moisture content decreases, energy has to be applied to extract moisture from the soil. It is just suppose one well is there. If well is full of water, we need very less amount of energy to extract the water. And if well is having less amount of water, or if water is present at low levels, more energy has to be applied to extract the water. And it is similar only. As soil moisture content decreases, more energy has to be applied to extract moisture. And the shape of this soil moisture characteristic curve in clay soil is straight line with bends on ends. In sandy soil, it is generally in L shape. In the next slide, we can see the graph, that is soil moisture characteristic curve. Here we can see, as we discussed, it is L-shaped in the case of sandy soils, and it is almost straight with the bends on ends in clay soil. Here we can see the relationship between water content and metric potential, that is soil moisture tension. If more amount of water is there, less amount of energy is required. If less amount of water is there, more amount of energy is required for extracting water. That is the concept of soil moisture characteristic curve. Next one is crop coefficient. It is denoted by Kc. Crop coefficient is the relationship between evapotranspiration of crop and potential evapotranspiration. Potential evapotranspiration is a maximum evapotranspiration, and crop evapotranspiration is general evapotranspiration recorded under field conditions. And this crop coefficient is depends upon soil cover, soil moisture, crop height, and plant growth stages. Generally, crop coefficient is very low at emerging stage, and it increases from crop emergence to, and it reaches maximum value at flowering stage, then declines as crop reaches maturity stage. Here we can see, here it is high at reproductive stage, followed by maturity stage, followed by vegetative stage, and followed by seedling stage. And in this image, we can see the crop coefficient at different growth stages. At initial stage of crop, it is very low. After that, in vegetative stage, it starts on increasing, and it has reached peak at reproductive stage, that means flowering stage. And after reaching flowering stage, again it started declining at maturity stage. That means it is high at reproductive stage, followed by maturity, followed by active vegetative stage, followed by seeding stage. This is also very important in terms of exam. Next one is crop tolerance. Crop differs in their tolerance to poor quality water. Generally, some of the regions will be having high amount of salts in the soil surface. So in those areas, we cannot grow sensitive crops. We should grow tolerant crops in these salty areas. Here we can see the different types of crops which are tolerant and sensitive to salts. In the next slide. Here, first we can see tolerant crops. In field crops, cotton, safflower, sugar beet, barley, all these crops are highly tolerant to salts. That means in saline soils, we can grow these crops. And fruit crops and vegetables, these are less important for our exam. And maybe they ask about forest crops. Bersim and rhodes grass, they are highly tolerant to saline soils. They can be grown in under saline conditions also. And next is semi-tolerant. Sorghum, maize, sunflower, bajra, rice, wheat, all these crops are semi-tolerant crops. That means they are neither tolerant nor sensitive. Forage crops like senji are semi-tolerant to salts. Next are sensitive crops. Chickpea, linseed, beans, green gram, black gram, all crops are sensitive. Just to remember, all pulses are highly sensitive to salts, so we cannot grow pulses under saline conditions. It is better to grow cotton, safflower, sugar beet, or barley. These are because they are highly tolerant. And the next one is moisture deficit. Moisture deficit in the sense, if there is if sufficient water is not present for plant growth, it is called as moisture deficit. And in this table, we can see different types of crops which are tolerant and sensitive to the drought also. Safflower, groundnut, pearl millet, they are low sensitive to drought. That means they can be grown in areas suffering from drought. And next is semi-sensitive, that is sorghum, finger millet, cotton, sunflower, castor, sugar cane. And these are medium sensitive. Next is wheat, upland rice, and pulse crops. They are medium sensitive to the drought conditions. Next one is lowland rice and maize. They are very high sensitive to the droughts. So in drought conditions, under drought conditions, we cannot grow lowland rice as well as maize. Next one is relative water content. Last year they have asked this formula, relative water content formula: fresh weight minus dry weight divided by turgid weight minus dry weight into 100. It is the ratio of actual water content to water content at saturation. It is generally expressed in percentage. This actual water content is obtained by subtracting dry weight of sample from fresh weight, and water content at saturation is the difference between saturation weight and dry weight. You should remember this formula, formula of relative water content. Based on this relative water content, ACO classified water stress into 3 types. That is mild stress, moderate stress, and severe stress. First one is mild stress, a drop of relative water content by 8 to 10% compared to plant in well water conditions. Well water conditions in the sense, if there is sufficient amount of water present for plant growth, that is known as well water conditions. Compared to that condition, drop of relative water content by 8 to 10%, it causes mild stress. That means drop in plant water potential by -5 to -6 bars. Next one is moderate stress. It is a drop of relative water content by 10 to 20% compared to plant in well water conditions. It refers to drop in plant water potential by -11 to -12 to -15 bars. Next one is severe stress. It is the drop of relative water content by more than 20% compared to the plant in well water conditions. It corresponds to the drop in plant water potential by more than -15 bars. These three concepts are very important. You should remember this one: mild stress, moderate stress, and severe stress, for example. Next one is salt index. Salt index is related to the quality of irrigation water. It was given by scientist Puri. It is also used to predict sodium hazard. And quality of irrigation water is defined by so many concepts like residual sodium carbonate. We already know about electrical conductivity, residual sodium carbonate. This is somehow very important concept. Salt index. Formula of salt index is total sodium content minus 24.5 minus calcium content minus calcium carbonate multiplied by 4.85. It is used for predicting or identifying the quality of irrigation water. If salt index is negative, that means minus 24.5 to 0, that irrigation is of high quality. And if salt index value is positive, that means quality of irrigation water is low and should not be used for irrigation purpose. And the salt index, it is calculating fertilizers also. It is the ratio of osmotic pressure produced by fertilizer to that produced stream weight of sodium nitrate based on relative value of 100. Here we can see salt index value of different kinds of fertilizers. For ammonium sulfate, salt index value is 3.25. For diammonium phosphate, that is DAP, it is 1.614. For potassium nitrate, it is 5.336. For sulfur, it is 3.06. And this is also very important for exams like salt index of different kinds of fertilizers. Next concept is water use efficiency. This is relatively easy concept. It is defined as a ratio of quantity of dry matter produced to the total depth of water consumed during crop growth season. Here we can see the formula, crop yield divided by water consumption. This was introduced by Briggs and Shange in the year 1913. The units are kg per hectare centimeter, or kg per hectare millimeter, or kg per meter cube. And two types of water use efficiency are present: crop water use efficiency and field water use efficiency. First one is crop water use efficiency. It is the ratio of crop yield produced to the amount of water depleted by crop in the process of evapotranspiration. Here we can see the formula: yield divided by evapotranspiration. That means yield produced by evapotranspiration of the crop. And the next one is field water use efficiency. It is the ratio of crop yield to the amount of water used under field conditions. That is yield by water requirement. That means water used under field conditions. And difference between crop water use efficiency and field is, here denominator is evapotranspiration, and field conditions, denominator is water supplied to the field. In this graph, we can see the relation between evapotranspiration and grain yield. Generally, if evapotranspiration of crop is high, biological yield will be very high. That means water use efficiency also, it will be linear. That means it increases, it goes on increasing. Here we can see the water use efficiency of different crops. For rice crop, water use efficiency is very low, that is 3.7. For finger millet, water use efficiency is very high, that is 13.4. followed by wheat, groundnut, and maize. Even water use efficiency differs from varieties to varieties. Among wheat varieties, Kalyan Sona variety is having highest water use efficiency, that is 14.4 kg per hectare mm. And you should remember these units of water use efficiency also. In exam, they may confuse you with by giving different kinds of units. Next one is for Sonara 64, water use efficiency is 0.3. For NP 718, water use efficiency is 9.4. Even the C3, C4 CAM plants are these generally water use efficiency is very high for CAM plants, followed by C4 plants, followed by C3 plants. And recommended books for this irrigation chapter are Irrigation Agronomy by SR Reddy and Efficient Use of Irrigation Water by Almanda Reddy and Shankar Reddy. And you should be thorough with these two books. And in Reddy and Reddy book also, Principles of Agronomy, that irrigation chapter is given. You should read that one carefully. Thank you.
Thank you, Karthik, for very nice presentation on all the aspects, small aspects of irrigation related to irrigation. Almost all, other than methods and scheduling, you covered all the important aspects in brief. It's very nice. And Karthik, you have poll?
Yes, sir.
Okay, then you can send that poll link to chat box. Is Devdatta is there? Yes, Amma, Devdatta? Yes. Karthik, you send that screen display not shown. Actually, here there is no display now. Okay. Karthik. Yes, Karthik.
Yes,
There is a small poll regarding this class. Poll means some quiz. Yes, Karthik, that you say that one. That is in PPT or you are prepared with that link?
It is in this our Agri-Challenge Academy law, that ID, sir. That poll.
Oh, okay, it's okay. You share that link in chat box. I think Devdatta is not there.
Sir, I joined with my ID, that's why.
Just a minute. Yes, friends, there is within 2-3 minutes, poll will start, quiz will start. Try to attempt, and it will also is a very nice platform for polls. It will display your leaderboard also. And regarding irrigation, whatever the concept delivered today is very important and basic concepts. Coming to irrigation in competitive exam of perspective, that may be JRF, SRF, or NET, or maybe some AFO or whatever it. One is units, another is numericals, and other is quantities. These are the important aspects. Other than that, quality of irrigation and drainage aspects also are important. And other than this terminology, this irrigation constants, different constants starting from saturation, then field capacity, then hygroscopic, then coming to your hygroscopic, then permanent wilting point, temporary wilting point. Other than that, there is a one concept is called as PF. It is has like a like your pH concept. There is another concept is PF concept, that is also an important concept. And these are the some important. Other than that, scheduling of irrigation, then coming to settling up and methods of irrigation and different methods and their efficiencies and the slopes followed in your surface irrigation methods. These are generally important aspects. And you can check last 3 years or 4 years net paper or some of the SRF JRF papers. There is a the weightage for irrigation management, including your irrigation related with soil and water conservation, is more compared to other aspects. Okay, then we have another demo class on agronomy in next week. I will intimate the date of the class. And Devdatta, are you there?
Yes, sir. Yes, sir.
Yeah. Shall we start, Paul?
Sir, just a second. Just a second, sir.
Yeah, Paul going to start. And all of you attend our next class. And after that, you will decide what about if you want to join our 1 year program, you will decide to join. Otherwise, as your wish. We are telling just compare the subject quality. We cannot give you that quality means of videos, that colorful videos, but we will give a quality subject. Actually, here no power at my place, that's why my video is not I think it's blur. Okay, we can't conduct classes in that visual rooms, but we will teach you subject. That's what we are. We will give you a quality subject. And friends, you may know that from this year 2020 JRF SRF, the ICR and NTA, it changed the pattern of examination. It's completely different as previously. Previously the facts and figures, it's enough, means those are remember more, than they will get good rank. But since this year they are converted to concept oriented classes, questions. So assertion and reasoning type, statement type questions means your concept must be clear. Otherwise, you can't answer any questions.
Sir, who started, sir?
Yeah, started. Hello.
Hello. Yes, sir.
Started, Amma.
Yes, sir.
Okay. Students, all of you just attend the poll.